I'm going to try to rip through this as fast as I can. This is how I make halo lit aluminum letters for commercial signage. First we're going to import the vector. I'm just using an SVG I have. I'm going to hit T for transform to resize it. Make sure that my aspect ratio is locked. I'm going to change it to 7 inches. My total size is 7 by 8. Next we're going to prep the file. I do fillets on all the internal corners, so I'll use this fillet. I will fillet them to a radius of 1/16 of an inch because I'm using an 1/8 inch bit. So I should be able to click on these corners, change them, all the internal corners. Internal, not these external ones. So this internal one here, yes, but not these external ones. When you hover over it, you can see the little crosshair change, and it'll let you select it. Sometimes you get an error like this about it needing to be a span or an arc or a line instead of a span. To change that, you can hit N or select this for your node selection tool. Click on it. I can see the problem here is just going to hover over this one, select it, hit D for delete, and then I'm going to change this line into a line by either right-clicking on it and hitting convert to a line, or you can hover over and hit L. I know that there's the same problem on this side, so I'm going to delete this one by hitting D, and then I'm going to convert this to a line by hitting L. You're going to have the same problem here with all these ones. So these are arcs instead. You see these lines, these mean they're spans, but if I hover over it, I can hit right click and convert to an arc, convert span to arc, and you can see it got rid of the arms and put a dot, or you can just hit A. I'll do the same things in these corners here that I don't like. I want nice radiuses. And then if I hit F, it'll give me my fillet tool again. So I can hover over these corners. And you can see these sharp parts. I like to clean these up. There it is. Okay, so the next step is to group them all together. So you can hit Control A and then Control G, or right click. This would be Control U. If you ungroup them, do it again, it'll group them. The next step is to set up the offset. So offset you set up by going here, this tool on the side, offset. We're going to do a inward offset of 0.1 of an inch. 100 thousandths. I'm going to hit offset. This is a radius to offset instead of a chamfered or a sharp one. I've had it selected. Doesn't make a difference. I got to now fillet all the corners on this one. So every corner should be nice and round. Might have to fix that with the node tool. Something wrong in here. We'll see. And if I hit fillet, yeah. So I see. I'll delete that one and convert this one to a line by hitting L. Go back to fillet tool. few left here. Let's go around the whole thing. Okay, looks like I got them all. I will select the selection tool, and we'll we'll select all of these internal offset and group them with Control G. Then I'm going to do another offset off of this offset. This one is now going to be an outward offset of 0.04. Offset that. This is going to be for a lip that the acrylic can sit on. Acrylic diffuser. We don't really need to do anything except for that, except for group it, so hit Control G. One more thing we should do, which would normally be done in your CAD software for if you had a whole sign with a bunch of letters, is you would have your pinpoints, so that way you could print or plot out your pattern, is have all the pinpoints on your paper. I use a 0.136 size hole, 0.136 of an inch diameter. That is a size for a threading a number 832 bit tab. So a move for something this size probably only needs a few tabs. You can hold Control when you're moving it, and it'll add another one. So select it again, hold Control, select again, hold Control. Move this one a little closer to the edge, I guess. And I will also add another hole here, somewhere in the middle. That's about 3/16 of an inch, 0.1875. That's for the wiring. One remaining step now is to reverse or mirror this. This will be cutting it backwards. So I just select the mirror tool on the side, and we'll just horizontally center it. Close that. Okay, now we'll set up the toolpaths. To do that, we want to make sure our material is set up right. So our material is 1/2 inch. I'll be using a 1/2 inch aluminum. I was setting the material 0 to the bottom, which means you set your bit to the surface of the table, not to the top of the material. Hit OK. First things are going to be the pockets. I'm using 2 different size bits. For the whole job, I'll be using 6mm and a 1/8 inch, which is a 3.175 millimeter bit. The depth of the pocket will be 0.375. I set it up so that there's a final tool allowance of 0.1 for the 1/8 inch bit to clear up. And I set up ramps on the entrance for both bits, for the 1/8 inch and the 6mm bit. I prefer ramps on all toolpaths. So to do this, we'll select the innermost innermost vectors. Hit calculate. It's going to give me some errors about how many ramps it couldn't do, but yes, just hit yes anyway. It'll ramp where it can, and it won't ramp where it can't. I will simulate this too while we're here. So set up this pocket. We'll start out with the 6mm bit. We'll simulate this one. Do the 6mm bit. Now it'll do the 1/8 inch cleanup pass. selected this, so the next one, we'll turn that off here. The next one will be this lip. We want to select the lip. It's going to have a 0.09 depth. The material I will be using for that is 1/8 inch acrylic, 0.125 of an inch. But if it sticks out a bit out of the back, it's not a problem. It actually helps a little light shoot out to the sides a bit more. So I will select the inner vector, or sorry, not the inner, the middle vector between the outside profile and the pocket. This is going to be using an 1/8 inch bit, and I'll calculate that one. We'll simulate this. And that's what that'll sit on. Next is going to be roughing the outside, roughing the outer profile. So this is, I'm going to use a 6mm bit. I will leave 10 thou for a cleanup pass, and I'm only going down to a depth of 0.48, leaving myself 20 thou at the bottom. Select the outer profile, you calculate. And we'll simulate this one. See, it's got the outer profile. It didn't get into spots like this. And it didn't get into spots like these corners, which makes it look pretty ugly for the size of letter it is. But that's where this 1/8 inch semi-clean roughing bit that I'm going to do here next, which I actually have an allowance of 3 thousandths for another cleanup pass after that. This one we are going to cut all the way through. Going to be ramping again, same thing. I'm not giving you feeds and speeds and stuff because every machine is going to be different, and even my Onefinity is going to be different than your Onefinity depending on the stableness of your table, what kind of spindle you have, what kind of bit you're using, whether it's coated or uncoated. I can give suggestions, but everything's literally going to be different. And I don't really know how to use it on this machine particularly well yet. I've only had it for a very short period of time, and one thing I can tell you right away is it's lighter duty than I was expecting. So the semi-clean, we are going to select this profile also, and I will calculate this one. The semi-cleaning bit is basically going to run it with lots of passes. This is all going to have lots of passes. Just consider this another roughing pass. And it's going to go, and we'll simulate this again. You can see from the simulation that I'm doing lots of passes. But look how this corner changes. That's why. If you do it in one big pass, you will break your bit on that thing. It's like cutting with a spaghetti noodle. Little 1/8 inch, it's not very big at all. Especially on a machine that has a lot of vibration. Carbide doesn't like it. So the next thing would be this last 1/8 inch cleanup pass that I have. Now this 1/8 inch cleanup pass I have is going to go down in one pass. All the way down, and I'm also going to add a little bit of a lead in and a lead out. Not very big at all. It's only 10 thousandths on a 15-degree angle, but it should help just hide those entrance and exit marks. Hopefully. I don't know what the resolution of this machine is yet. So I'll click on that one, we'll go back, we'll select the profile for it, this outer one, hit calculate. See, it just added a very thin difference there. And if we zoom in on one of these, you can see the lead in and lead out is very small. And from here, we can simulate this one. It barely show up at all. I'll play it at regular speed. And that's it. You can barely even see anything. Now, From here, basically, we just are going to save these. So you can either click on the individual toolpath and hit save. It'll load that one up. You give it a toolpath name them properly. You might want to number them, name them with the bit name. Don't get them confused. Hit that save to your disk, move on to the next one. You can either hit close, go on to the next one, hit there, or you can move it back, move the next one over, hit save. Do that. Once they're all on the disk, bring them on out to your Masso controller on your Onefinity, and you can run from there. One thing I should add about these machines is they are relatively weak. Just not specifically the Onefinity, but all these like hobbyist machines. And you might have a struggle getting this 6mm roughing bit or roughing toolpath to go all the way. One of the techniques I've used for years is to add another one. So let's duplicate this one. I'll move it back up. And we're going to basically pre-rough this section. You can even do it in 3. Let's do it in 3 just because let's assume that this thing is made and you're doing it with like the Makita router or something. So I'll duplicate it again. The third one will keep the same. So this one would be your normal roughing path. But let's go with this one first. This one we'll start and we'll make an offset of 0.125. And we're actually only going to go down 0.875, 3/16. Okay, and we'll hit calculate now. And then this one here, the second one, we're gonna go down 0.375, and we're gonna tell it to move over 0.0625, so 1/16. We're gonna hit calculate there. So now the way this will work is, we'll simulate these. I'll delete the simulation. Where's the simulation? Oh, delete the simulation, reset it, and when we rough it, you'll see what I mean here. We'll rough this by going see the first one here will only go down this 3/8 or so, leaving lots of room for the chips to excavate. It won't get too deep just to cause a lot of rewelding. So then when you do the second pass here, it moves in a bit and it goes a little deeper. So what that does is gives room for the chip to leave, right? It's not just trying to suck it up the entire channel where there's no room for it, so it's rubbing against the walls. What this does is it only has to lift it up this little bit, and then it gives lots of relief. Then we do the third one, same thing. We're going to run it again, and it's going to hit bang, and you see how it now can get all the way to the bottom. And basically you're tricking the machine into treating it like it was a bunch of thinner materials instead of just one thick piece. It's just a tip. You might not need to do it, but if you do find your machine is struggling getting through the thicker material, this is something you can do. These are the bits I use. They're from AliExpress. They're a spiral low flute carbide bit with a rainbow coating, they call it. I think some companies call it a DLC, diamond light coating. It's just a cheap bit, but they work great. Slotting can be one of the hardest things to do on a CNC machine. That's why I was suggesting stepping it down into 3 stages. As you can see from the slow motion, that even here, edge cutting is tough on this machine. Here we've switched over to the 1/8 inch end mill, 3.175 millimeters. It's clearing everything that the 6 millimeter bit left behind. Okay, just finished the last roughing pass there or the semi-roughing cleanup pass, the 1/8 inch. And to be honest, it looks pretty good. I don't know if I'm going to need to run that last pass. This edge here looks really nice. So now this took about twice as long as I would do on the machines that I normally run. And the finish is, until I pop it out, but just looking at it, it's about 80%. So it would be hard to do this commercially on this type of machine from what I can establish just right off. But it's totally doable. So if you're not in a rush, you can put out some decent work at least. We are back in Carveco here, setting up the file for the acrylic. To do that, you want to select the holes for the pins, or the inner vectors, and I'll copy them to their own layer. So these ones you can move around wherever you like. I put them close to the edge of the sheet so I'm not wasting much material here. Let's go 0.2, 0.2, hit apply. Now with the toolpaths, I have 2 toolpaths set up. I have one set up for the holes. I'm using 3/16 acrylic. I thought I had 1/8, but I have 3/16. So the start depth would be 0.3125. The finish depth is 1/2 inch. I'm using a 1/8 inch end mill for this. I'm just using the standard setup that it had. It seems okay to me. 0.1 at 40 inches per minute. And I'm going to set up a ramping toolpath, a spiral, for the insides. Calculate this. The second toolpath I have is for the profile on the outside. Profile on the outside is a separate toolpath, pretty much the exact same settings except for it's set up for outside, and I have an allowance of 10,000, meaning it's going to cut an extra 10 thousandths off of the edge so that it will fit inside of the aluminum piece we've already previously cut. The settings are the same, start depth of 0.3125 and a finish depth of 1/2 inch. And this time I'll use a smooth ramp in, 15 degrees. I'll hit calculate. So I select the holes and I hit save. I will also move the acrylic profile over so that they're saved as one toolpath. I'll name it, save it off to the USB drive, and take it over to the Massa. Back in the garage, I've got the sign white acrylic taped down, and I'm about to run the program here. Okay, so it's all cut. Turned out pretty nice. I'm gonna put the LEDs in. The type of LED you use is a flexible 12 volt LED. Um, just a cheap kind you can buy off AliExpress or Amazon. And basically, I'm just gonna put these in and stick them in as best I can everywhere. Try to get them in as many of the corners I can. Sometimes it's hard to fold them over each other. But you want to try and get them up into as far up into every corner as you can, so the light can get into there. Okay, so I've got all the LEDs in, soldering done. Got them all glued down with the pigtail put on. For the backer, I have the spacers glued on here, and I've countersunk the wire hole on both sides so that it's nice and smooth for the cable to go through. I'll feed this wire through. So that's all pressed in, and I'll wire up this pigtail here. This little quick connect sort of attachment. Plug it in, we're all lit up. So when we flip this over, this finish. To highlight the effect better, I've put it on this matte white painted surface. The aluminum will be painted black, and this is what it would look like pretty much when it's finished. Thanks for watching.